So on this one we're just going to do a quick review of what each trigonometric graph looks like. So we'll do sine of x first. Remember, the sine of x has a period of 360 degrees, which is equal to 2 pi. So if you had to sketch this, and remember the one on the example went back into the negatives a little bit, so you might have to go back into that a little bit. But anyway, it's going to go out to 360 degrees, which is 2 pi. It starts right here at the origin, and the height or the amplitude is going to be 1, and it goes down to -1. So if you're, oops, that's a 2. So anyway, the amplitude is going to be 2, if you remember, because it goes up to -1 and down to -1. So that's a total of 2. So anyway, it starts here. It's going to cross the x-intercept right in the middle at 180 degrees, which is pi. And it's going to have a maximum height right here is where it's going to hit 1 at pi over 2 in radians, which is 90 degrees. And it's going to go down a minimum and hit -1 right here, and that's at 3 over 2 pi, I believe, over 200, which is the same as 270 degrees. Anyway, that's what you got to know. So it looks something like this. That's where it hits 1. Goes down through the x-axis. I kind of missed, but you get the point. And then back up and through here. So pretty simple. Now they may have you go back into here. It's just going to hit the. It's going to do the same thing going backwards. If we take this as 180 degrees, which is, or -180 degrees, it's going to go through. It's going to hit its low point right here at -90 degrees. So it's just continuing the cycle, going backwards. And there we go. And you could keep going either way. So that's the sine wave. Now some of you are asking, what happens if you put a number right here? This probably won't come up on the test, but say they put a 2 here. Alright, so it becomes sine 2x. Alright, that affects the period. So you basically take the period and divide it by 2. So that would take the sine wave, and I'll draw this new one in blue. The maximum would be in between 0 and 90, right here. The minimum would be right here, and it's just going to compress it. So, boop. Down here, and then up like that. A number in front is going to change that amplitude, so that will make it either taller or smaller. Don't forget, you always put this stuff in your graphing calculator to check and double check your work. So if you want to see what the period is, you put a 2 there. Remember, on your graphing calculator it's in radians, so most of you probably want to change it to degrees. And just look at the graph and see what happens at 180, see what the graph looks like. What does the cosine look like? It's very similar to a sine. The period is going to be 360 in degrees, pi in radians. Sorry, 2 pi. So it looked quite the same. And so we got 1 and -1. We want to use the same markings on our y. We got 360, which is 2 pi. In the middle we're going to have 180, which is pi. 90 degrees, which is pi over 2. That's going to grow. And 270, which is 3/2 pi. So remember what this looks like. We start here. These are going to be my x-intercepts, and my minimum point will be at 180. And then it will finish here. So it looks something like that. pretty simple. Again, use your calculator. Putting any numbers in here has the same effect as the sine. Again, just use your graphing calculator to double check what happens if you get a problem like that. Remember, the release question was the graph of sine. I would imagine maybe either the graph of cosine or the next one I'm going to show you real quick, tangent, would be what shows up on your test. So let's take a look at tangent next. So tangent is the one that likes to give us problems. The period isn't 360 anymore, it's 180, which is pi. So when you draw this one, the tangent would be, let's see, let's take it all the way up to 360 anyway. And 180. I'm not going to bother with well, we can do it. This is pi and this is 2 pi. So it's going to go to 180 degrees. That's where our cycle is going to end right here. So if you remember, we start by putting an asymptote right in the middle of 180 and 0. And so let's put an asymptote there. Remember, asymptote isn't technically part of the graph, so I'm just going to leave it. Now what happens is, starting here, the tangent starts at 0. Now it's going to go up, and it's going to almost touch the asymptote, but not quite. And what happens is, after the asymptote, if we want to, it comes up from the asymptote, almost touching it, and goes to 180. Looks something like that. So that's one period of the tangent. Now, then the cycle continues. So it's going to, in this dotted line, I'm just putting there for reference, and that would be right at 270 degrees. It's going to go up and down. Sorry, it's going to come up again and hit here. It's just going to keep repeating. So that's a tangent. Again, remember, if you do this one in the graphing calculator, it gives these weird lines here because the calculator doesn't understand that jump. So it could give a strange line like this. That's just an error that the calculator makes. So if that shows up, just ignore that part. And remember, that's not part of the graph. Again, use your graphing calculator to do this one. Use your trace function. Make sure you use degrees. And change your windows if you need to. To this one, you'd want to change it to an X max of 360 or more. And on your Y, you'd want to do probably 1 or 2. I'd probably do 2 and -2. That would give you a good look at the graph. So just use that, use your window to find points. So those are the 3 graphs. Those are the only ones that they said would show up on the test. So those are the ones I'd look at. And again, your graphing calculator is going to help you a lot with that.